Hello and welcome to today's video. So as most of you are probably aware, we purchased another house. We are in the process of moving to the new house. And one of my goals is to actually get the truck to move there under its own power. And so on the workbench today, we have essentially a simulation of the truck battery pack and the battery charger circuit. So right now we've got a NLG5 11 battery charger. It's hooked up, it's programmed in CAN mode and it's hooked up over CAN bus. You can kind of see the cable comes out, it goes around through this connector into my adapter to a Nissan Leaf here. I'm just picking up the CAN bus and ground. So it's pretty simple. That makes its way back over to this connector on the Pack Sniffer 2. We have Pack Sniffer 2, which is the brains of the operation here. The other side is connected to a Nissan Leaf battery pack simulator. So if you look inside here, I've got a little microcontroller that spits out CAN messages to make it think it's a battery. It's connected to a battery pack, and I can adjust the voltage and current here. The current sensor is not actually used, but the contactors are. So the pre-charge resistor and the contactors are hooked up. So you can see the other side here runs over to the battery charger and plugs in. Yeah, the other side is going to my thing so I can turn it on with one hand here. So that's all hooked up, and then this is actually connected to a battery. It's my really old anemic battery pack over here. We'll put a load on it, get it to turn on. And let's see, to power the Pack Sniffer 2, I am running off USB, which is supplied via this cable into my battery or my power supply here, and I turn on just by clicking channel 3 and we'll get 5 volts. And then there's a ground wire that I've hooked up to get myself a common ground connection between the power supply and the battery charger. Well, not common ground, but common DC for the CAN bus, essentially, or not for the CAN bus, but for the charger enable line. So yeah, I think that's everything. Oh, and then we've got the voltmeter kind of hanging off here, which I should probably turn on. And we'll read some voltage here. Yeah, so we've got nothing, and we have a low battery. But anyways, I think we're ready to go. And yeah, first thing I'll do is actually connect up a load, because the battery pack's pretty dead. And like dead, like the batteries themselves have really high internal resistance. So I'll hook this up. Probably be a little bit of a spark. And that just turns on the bulbs over there to give the charger something to actually charge against. And now we're ready to turn on. So I'll go ahead and click the button here. And then we'll go real quick to the Pack Sniffer. So there you go. Oh, I don't have my charger plugged in. So essentially we're looking for the charger or the ignition line, charge line or the ignition line to go high. We don't see it, so we actually go to sleep. So what I need to do is I'm going to come over here and I'll plug this in and we'll record that. So I just plugged it in, charger detected, and we found a NLG5, and then that's the mains voltage. I'm running off 120, so that's bridge rectified AC. We're going to pre-charge the battery pack. Oh, we're going to read first, yeah. And when we pre-charge, we'll see the voltage come up here. So it's switched over to using the charger now. And yes, my battery pack is only at 92 volts. Now we're going to start the battery charger. And now we're up to 156 volts. And we're drawing about 1.3 amps. And I don't know if you'll be able to tell, but the lights are significantly brighter now. And we're on the very hairy edge. Every once in a while you'll hear a click. It's actually the fans in the charger spinning just a little bit, because we're right on the hairy edge. But yeah, this is all up and running. So now what we're doing is we're just showing the high voltage bus and how much current is as measured by the battery charger, because this is all simulated. So as soon as it gets data from the battery charger, I switch over to show that. And my state of charge and health is fake. It's coming from the micro there. But the actual cell voltages are live. Like if I were to actually move the voltage pot here, you'll see that that actually changes them next time it comes around. So I'm at 3.9 volts. If I move a little bit more, 3.96. So what I can do is if I hit 4.1 volts is actually where I told it to shut down. So I don't know if I want to hit that yet though. Yeah, well, let's leave it right there for now, and I can put a bigger load on here. So right now I just have those lights hooked up, but I can hook up the big light, and we'll draw a little bit more current. There might be a bit of a spark. So now the big light's on. You can hear the cooling fans came on the battery charger here. And if we now look, I told it I want 156 volts with a max of 5 amps. And so we're now current limited at about 5 amp, or yeah, around 5 amps, 4.95 amps, and we've dropped down to 139 volts, which is what the meter's reading here, pretty close. So that looks like it's working, and it looks like we're actually discharging. Our voltage is actually dropping. So I'm going to go and take off the big load again here and let that go back down. So now we're at you can hear that the cooling fans on the charger died or shut down, but yeah, see, we're at 1.5 amps now, still maintaining 156 volts. And there's one little, let's see, what else do I want to show? Oh, if I give it just a little bit more voltage here, we'll kick it out at 4.1 volts. And then I'll give it a little bit more. Pot's actually pretty sensitive because it's 0 to, I think it's 0 to 400 volts. That's what I made full scale. So where are we at? Oop, we're getting close. Give it a little bit more. There it goes. So one cell reached 4.1 volts. We shut down. Charger's now off. And so we're decaying. We're no longer at 156 volts. And that should show it here too. Yeah, we're dropped down to 125, which is what this is saying, is that we're dropping down to, and the bulbs are significantly dimmer. So I don't have a fancy screen that says charge complete yet. I haven't written that code, but that's the basics of it. It looks like it's all working. Like I said, this is simulating the battery pack. In reality, it would, I know when it boots up, it says it's around 300 and some volts, but it'll actually be, around 150 volts in the actual truck. So all it's looking at right now is those two cells, which are the high and the low cells. State of charge and health are fake, but yeah, so those are the high and low cells. And oh, we're down to 60 volts. I should probably, oh no, actually this says this is reading, we're not actually that low voltage. This is on the other side because we're on the relays have closed, so we're actually, or opened, so we're actually reading the voltage across the capacitors in the battery charger right now. That's decaying. If I were to move the voltmeter over to the other side here, I can measure like that. See, we're actually at 92 volts and dropping, which is really anemic for my battery pack, but that's just because it's on its way out. So let me get rid of the load on this so it doesn't drain it completely, what's left of it. But anyways, it looks like everything's working. I can throw in some more little screens and stuff and make it, more useful, but I don't know if I'll have the state of charge cycling. I kind of I might make a screen that literally just has, charging voltage and current and high-low cells. Maybe I'll compact it all into one screen. I don't know. I haven't decided yet. But proof of concept, it's definitely working. That's always good. Anyways, yeah, progress is being made. Thanks for watching. Bye.